Hi, it's Tim and welcome back to the corner. Today we've got the CD32 on the bench again, and now we have got a replacement laser. So let's fit it. So I've taken the lid off, and what we want to do now is take the laser assembly out, and to do that we need the 4 screws that hold the thing down. So we can take the unit out. So the entire assembly should now come out. Put that to one side. Here it is. So before we go any further, I'm going to put the anti-static wrist strap on, because this is an ESD sensitive device. What we'll do next is we'll take this sled off the back tray. So unplug the red and the white cables. There we go. Now we can take the laser assembly off this sled. We need a smaller screwdriver. That seems to be the right size. Never done this before, but I've watched videos, which makes me, in YouTube terms, immensely qualified. Should come out. There we go. Put that to one side for now. So in order to get the laser assembly off, we need to remove this white cog. To do that, from this end we can just pinch the end in. There we go. And that should just come off. Now the laser will slide. And to get that off, we need to remove this rail. And this rail is held in by these little plastic clips here. So I'm going to push that far enough. There we go. This should slide off. And it does. And it won't come out because it is held in place by this plate here, so we need to undo that. And that is an even smaller screw. And out it comes. Now, one thing that we can see on the board just here, this is an ESD splodge, and we will need to unsolder the ESD splodge on the replacement unit, and it should just drop in. I want to thank PCBWay for sponsoring this video. PCBWay produce printed circuit boards for just $5 for 10 boards, whether they are shared projects like these or whether they are your own design like this. PCBWay will produce outstanding quality boards for just $5 for 10. They also do CNC machining, 3D printing and a whole host of other things, including PCB assembly and flex PCBs and advanced PCBs. Check them out, www.pcbway.com. So anti-static protection. Okay, let us verify that we have the same unit. KSS210A, KSS210A. There is the ESD splodge. So let's just warm up the soldering iron. I think all we should need to do is just unsolder that. There we go. So to fit it, we just reverse the process. Now fitting this back is slightly more delicate. We have to make sure it engages with the teeth. There we go. And we'll put some grease on there in a moment. Okay, that's the laser fitted. Right, let's connect it up. Okay, the wires are in. That's a good start. Let's just try a CD. Well, that's interesting, no difference. Let's do the tip it upside down trick. After going through my entire stack of discs, I found that most of the actual CD32 discs and the CDTV discs do work, and you can see This is Liberation actually on the screen, but the music CDs mostly don't. So I think it's time to look at calibrating this and see if there's something that we can tweak and adjust and hopefully get things to be better. Let's take the machine apart again and do that. So I've taken the CD32 apart and I have noticed a problem. When we recapped this machine, we thought that these two capacitors were in backwards, and stupidly now they are. In fact, if you look carefully, let's see if I can zoom this in, you might actually see that these are bulged, so they're definitely in backwards and they've definitely started to fail. And we can prove this by looking at the negative lead. The negative lead is on that side and on that side, and we can check this against the ground. So I've marked, let me just turn this on and set it to beepy beepy. So I've marked each capacitor with a little black line so we can see where it is. And this is the ground, this is our main ground. So we can see that is connected to ground, which is that end, not that end. And that is connected to ground, which again is that end, towards the switch. And I'm sure I said, or at least I thought I said, towards the switch before, and double checked it, but of course I haven't, and it's wrong, and we need to replace those. So yeah, we're going to do that. Unfortunately, I don't have the exact same capacitors because this came as a cap kit rather than me just buying a load. And so I've got these, well, basically junk capacitors of the same size. They're slightly smaller physically. They are 1000 microfarads but 16 volts rather than 10 volts. And you can put a slightly bigger voltage capacitor in there with no trouble. What you can't do is put a smaller voltage capacitor in there. So we're going to replace those. Whoops. So we're going to replace those with these. Yeah, the junk, but at least they'll be in the right way around. The next problem that we've got, and I noticed this while I was testing the CDs off camera, the left audio channel is not working. So all the audio that we're having is coming out of the right channel and nothing is coming out of the left channel. So I'm going to investigate that, and I don't know why at the moment. I have printed out the audio circuit. As you can see, this is the right channel, this is the left channel. I've already beeped these out. This is capacitor on that right channel, this is capacitor on the left channel. They are correctly connected, so this is the right channel, this is the left channel. They go to these capacitor and I think it's a inductor or something. Anyway, they go to these two components here, so that's the left channel, that's the right channel, goes to that, goes to that, then through these two capacitors to this amplifier, which is that. So I've identified where the circuitry is and I've beeped out the connection from there to there. Let's just show you. Okay, so right channel goes to there, left channel goes to there, and then this side, oops, this side goes to here, and this side goes to here, and it's 470 ohms, and then it goes to this. So these are in the right way round. So I don't know what the problem is there at the moment. We will have to have a look. So let's get these out. Put some flux on there and some fresh solder. Remember, we had trouble with these the last time, so I'm going to turn the iron right up. So in fact these are actually marked correctly on the board. Right, you can see the negative is actually the slightly bigger pad. Double check that, yeah. Sorry nice capacitors, you've been replaced by cheap and cheerful ones, but double check negative is towards the switch, negative is towards the switch. So now let's look at the laser. And I've got my strap on. So the unit that we've put in, if you can see it, this little pot is basically glued in on this laser. And the way it's oriented is that towards the top you've got the little numbers. Now on this one, if you can see it, the little numbers are about 45 degrees. So one thing that we can do is make a starting point and just adjust this. This is not glued in, so we don't have to unstick it. But we can adjust that so that this is basically pointing the same way as the other one. And we can use that as a sort of basis to start from. So we can adjust that like that, so that that is in the same position as the other unit. Now, I didn't get around to this before, but before we start putting it back together, let us grease the cogs. Now, I have got lubricating grease for plastic components, Molykote EM30L. This was recommended by Gadget UK. So it should be good stuff. It's not cheap stuff, that's for sure. And basically what we do is we just put a little bit on here. Right, now I've also taken the weight out of the lid of the CD32 so that we can put a disc on there and that will hold it down. Shall we try it and see if that has made a difference? I'm going to have to place this over here simply so that this will plug in, and I'm going to need to put something underneath it so that it doesn't short everything out. So let's do that. Be back in a sec. Okay, plastic lid from IKEA, that should do the trick. So this is able to freely move. And what I'll do is I will stick the CD in the system and put this on the top and then power it on, and we'll see what happens. Okay, that is exactly the same. You can see it's spinning it up and then stopping it. Ah, that's interesting. After a while it's come up. And what I notice here actually is it's spinning it that way round. Let's turn it off. And I think when it didn't work, it was actually spinning it the other way. Let's try it and see what happens. Let's come up again. That is interesting. So I think when it didn't work, it was actually trying to spin it backwards. I'm not going to play the disc, one for copyright reasons, and two, I haven't got a controller plugged in. But that is definitely reading it. Now, to calibrate this, we are going to have to take it apart. So let's disconnect that. We need to take this cap off, this lid off, to get at the pots that are underneath here and the test points. Right, so we have pots and we have test points. Now the first thing that we want to do is measure the resistance on these pots so that we can get them back to their original position. It's not just a matter of marking them, but we need to know the exact resistance. So let me get my notebook, and then we're going to go from this end where this big capacitor is and check the resistances from, doesn't really matter I suppose which side, but that side to there, or that side to there, or that side to there, for each of the 4 pots, and also for this pot here. Right, so go for this one on the left side, 6.26K, and on the right side 14.8K. Okay, so we know our starting values. So now we want to connect some wires to various test points on the back of this board. And the test points that we want are VF, FEO1, TEO1, RF0 and ground. And I'm going to use this screw here as ground. So I've pre-cut and tinned a bunch of wires. Okay, it doesn't really matter what colour goes to what as long as we know which is which when we come to test it. And the reason for this, of course, is so that when we're testing it, it's going to be that way up, and we won't know, we won't be able to put a probe on there. Okay, so first of all we're going to measure, adjust these 2 pots, then we're going to adjust this pot, and then finally we're going to adjust these 2 pots. So let's set this up. So for the first pot, which is TEB, that is the tracking error balance, we need to be connected to TEO1 and VF. Now VF is yellow, it doesn't matter which way around we do this, it's going to be on the multimeter. So TEO1 is green and VF is yellow. And we want this to be in millivolts. So power it on. And now we adjust this pot until the millivolts reading is as low as possible and definitely below 1. We're starting off at 1.8. That's going up. That's as close to 0 as it's going to get. The scale doesn't go any lower than that. The second one is FEB, focus error balance, and for that we are connected between VF, which is the yellow, and FEO1, which is the blue. So we move that across to blue. Power it on again. And again we are looking for the lowest voltage. See, I'm barely touching it and it's moving quite significantly. Zero point 0.9, that is below 1. We'll go with that for the time being. Now we're going to have a go at setting the laser output itself, and for that we're going to use the scope. Okay, and the scope goes between ground and RF0, which is the red one. We need a audio CD for this, so there we go. Okay, so we've set the scope to AC coupling. Turn him on. Now the waveform we want to have is going to be 900 millivolts peak to peak. That's what we're looking for. Okay, so okay, this is my third go at this. Hopefully it's going to work this time. So I've got the laser unit set up on top of the CD32. The top unit is plugged into it. That's just so that the lid will work and the lights and the buttons and so on. There's a disc, audio disc on the CD. The audio is not plugged in, so we're not going to hear it. We're not going to worry about copyright. And the test leads are plugged in. I've shortened this one because I think maybe having the longer lead was causing a problem with the signal. So we are connected to RF0 and ground, which is the red one and the black one. Let's power on the unit and see what happens. Okay, it's come up with the CD interface, and then we can have a look at the scope. So this is kind of an approximation of an eye plot, and it's a bit dim looking at it down from the top, but the way we get this is basically we are triggering on both up and down edges, and we have got persistence set to several seconds, so that's leaving us the traces on the screen, and that's giving us an approximation of an eye chart. Not a very good approximation, but it is an approximation. The dotted line is set at 900 millivolts, well 904. We're looking for about 900 millivolts. Now the pot on the laser is actually set to the factory position. I reset it after playing around with it before, and that's giving us approximately 900 millivolts. You see, it does occasionally blip over, so that is in fact about right. The next test is tracking error balance, which is the first pot, and this is between VF, yellow one, and TE0, which is the green one, and we need to get less than 1 millivolt. You'll see we are currently on -20. Actually, I suspect we need to do that without a disc. So let's measure it without a disc. It's 2.6. That's as close to 0 as we are going to get with this multimeter. And now we want to measure FEO, focus error balance, which is the blue wire, again between yellow and blue. And once again we are adjusting the pot to get below 1 millivolt. This is incredibly sensitive. I'm barely touching it. There we go. That's going to be as close to 0 as we can get it, 0.1. There we go, that's going to do. So now pot number 3 is the tracking error gain. That is between ground and TEO1, which is the blue, sorry, the green. And we need a CD for this. Power it on and let's have a look at okay, right, we've got it. That's our waveform. Now we want to turn this fully clockwise so that the waveform goes all squirrely. And then turn it back so that it is stable. I think that's stable. I'm not sure about those odd spikes. Let's go on to FEG, focus error gain. Right, so that's between ground and blue. So we want to switch that to 20 millivolts per division. We can change the time base to 2 milliseconds. Right, once again we turn it all the way clockwise. So we get a horrible waveform. You can probably hear that, that's the coils, it means we've gone too far. Is that about right? So I've spent the past 2 or 3 days playing CDs on this machine and various games and stuff almost non-stop, and it seems to be holding up pretty well. It's not skipping, it's not misreading the discs, it's doing fine. I did manage to fix the sound problem. Unfortunately, I didn't film it, but the problem was basically one of the capacitors had a little very tiny solder bridge that I could barely see even with the hand magnifier. So I guess it's a point in favor of getting a microscope. So, and on star. Anyhow, if you've got this far, thank you for watching, and please like and subscribe and do all the YouTubey things. Thank you to my patrons, who are wonderful if few in number. Please check out my Patreon. Every little helps, as they say. And so, thanks for watching, and we'll see you next time. See ya. Bye. Ah!